Hello everyone, welcome back to my channel, Mambalot's Math Tutorial. This time we will discuss the x and y intercepts of a polynomial function. What is an x-intercept of a function? It is where the graph of a polynomial function crosses the x-axis. For example, if we have this graph, so the x-intercepts are -5, 2, and 6. And what is the y-intercept? It is where the graph of a polynomial function crosses the y-axis. So if we have this graph, our y-intercept is -2. But what if we are given the function itself and not its graph? So for example, find the x and y-intercepts of p of x is equal to 2x cubed minus x squared minus 13x minus 6. So if we go back to our graph of our x-intercept, the ordered pairs there for our x-intercepts are -5, 0, 2, 0, and 6, 0. Observe that all the y-coordinates of our x-intercepts are 0. So to be able to solve for the x-intercepts, we must make our y equal to 0. And for the y-intercept, the ordered pair there is 0, -2. So to solve for y-intercept, we will let the x equal to 0. So going back to example number 1, we have the function 2x cubed minus x squared minus 13x minus 6. We can also express this one as y is equal to 2x cubed minus x squared minus 13x minus 6. Since p of x is just an expression that it is a function, so we can just substitute it by y. So to solve for the y-intercept, we will substitute x equal to 0. So that becomes now 2 times 0 cubed minus 0 squared minus 13 times 0 minus 6, which becomes 0 minus 0 minus 0 minus 6, which is equal to -6. So this -6 is what we call the y-intercept. Observe that our y-intercept is always the constant term a sub 0 because we substitute all the variable x to 0. To solve for the x-intercept, we must let y is equal to 0. So from that function, we have now 0 is equal to 2x cubed minus x squared minus 13x minus 6. So to solve for the values of x, we will use the synthetic division method. We have the coefficients now of the functions, which are 2, -1, -13, and -6. So we try the value here, which is 3. So we bring down 2 times 3, we get 6. Minus 1, we got 5. Times 3, we have 15. Minus 13, we got 2. Then 2 times 3 is 6. Minus 6, we got 0. So 3 is one of the x-intercepts of that function. We will try another one, which is -2. So we have to bring down 2. Times -2, we have -4. Plus 5, we get 1. Times -2 is -2. Plus 2 is 0. So -2 is another x-intercept of this function. Another one is -1/2. So we bring down 2 times -1/2, we get -1. Then plus 1, we have 0. So these three numbers on the leftmost part are the x-intercepts of these functions, which are 3, -2, and -1/2. You have to take note also that the x-intercepts are also called as the roots of the functions and also the zeros of the functions. So these three always go together. Example number 2. Find the x and y-intercepts of p of x is equal to x times x minus 3 times x plus 4 times x minus 5. Observe that our function here is in factored form. Nevertheless, we will still use the same method that we used in example number 1. So to solve for the y-intercept, we will let x is equal to 0. So that becomes now y is equal to 0 times 0 minus 3 times 0 plus 4 times 0 minus 5. So that becomes y is equal to 0 times negative 3 times 4 times negative 5, which is equal to 0. So our y-intercept here is 0. To solve for the x-intercept, we will let y is equal to 0. So from that function, we have now 0 is equal to x times x minus 3 times x plus 4 times x minus 5. So since this is already in factored form, we can automatically equate each factor to 0 to find x. So that becomes now x is equal to 0, x minus 3 is equal to 0, x plus 4 is equal to 0, and x minus 5 is equal to 0. So solving further for the values of x, we have now x equals 3, x is equal to negative 4, and x is equal to 5. So the x-intercepts are 0, 3, negative 4, and 5. So now it's your turn to answer your activity sheets. Don't forget to like and subscribe. At your service, Ma'am Balot.